All right, here we go. So today is projectile motion. We're going to do a bell work problem. As we go through this, similar to yesterday when we were kind of letting all of these concepts marinate, today is your chance to kind of dig in, ask questions, help solve the math. So the first thing we're going to do is I called it bell work, but really this is the problem that we're going to work on today. So in your notes, I want you to write down this problem because I'm going to go back to the whiteboard version of this. So I want you to have the data. I want you to write down, maybe not draw that whole thing, but at least write down the question. Hey, a football is kicked. Here's the initial information. And then also write down the 3 different questions that we're going to solve throughout the hour. And again, on a test, obviously you'd have this in front of you, but for today, as we go through this, I want you to have it handy. Bless you.
Thank you.
We'll have to edit that sneeze out in post, you know. Or at least hit the mute button before the next sneeze. You know, I mean.
Thank you.
All right, so yesterday we were tossing a tennis ball, dropping a tennis ball, throwing it back and forth. Today we're going to consider kicking a football. So similar, samey, a little bit different, and I don't think that really matters, right? Because ultimately it's the motion of whatever we're talking about that matters, whether it's a cannonball or a football or a baseball or a, well, you'll see later today, a stunt driver riding a motorcycle off a cliff. Let's do that too, right?
Yeah. We're going to test that one?
Yeah, come on. So everybody got the details of this in their notes? Okay, so let's get a blank screen so we can start. Oh, wait, too soon. Maybe next time I print this out and hand it out. Next time. Someday I'll be good at this. Someday. With your help, I can be a good teacher. Okay, we got it?
Yeah.
Close enough? Well, so I'm going to draw my own picture. I know several of you. Football. Is this what we're talking about? Fancy artwork? We did it?
Yep.
Okay, so let's review what we're talking about, right? So we're talking about the projectile motion of a football starting basically the instant that you kick the ball, right? Starting with it having some initial velocity in some direction. The details were in the question. And then ending essentially when it hits the ground some distance away, right? So that's our scenario. And again, this is what will change based on motorcycles and footballs and baseballs and all the different things, right? But that's really what we're talking about. So at its initial instant, that is the details of that initial vector for velocity. What were the details of that in your notes?
37 degrees.
37 degrees, up from horizontal, and 37 degrees. So this is what we're talking about? This is our initial condition. This is the initial kick of the ball. So right when it's kicked, it has some velocity. And in this case, football, it's got some velocity and an angle above the horizon. Okay? How does that information help us with what comes next? Solve for what? So we can break this into horizontal motion, right? The outward motion, and we can break this into the up and down motion. And if we use the horizon and the vertical as perpendicular measurements, we can turn this into this, which now allows us to what? Trig. SOHCAHTOA. So we have some total velocity in some direction. Well, let's break that into velocity in the x direction and velocity in the y direction. So using your SOHCAHTOA in your notes, solve out this triangle. And again, this is where we're kind of bringing this all together. Why did we start on this trig stuff weeks ago? Why did we talk about vectors weeks ago? So that we can get to here. And now we can use those tools to solve out some of the details of this motion. So grab your calculators. Again, make sure you're in degree mode. Solve out this triangle. And now again, I recommend you be methodical in your notes. Write down what we're solving, plug these things in, because you're going to see we're going to need this more than once as we answer the questions that are in here. Perfect. Nice job. Good. Units, bro. Come on. Okay, so I think most of you have gotten this. What is our horizontal component of our initial motion?
15.97 meters per second.
How many?
15.97. I guess we should.
Trying to sneak in an extra sig fig on me? Carson, go get the phone. Go, go, go. Go, 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 go.
Run, Carson.
Be a gentleman on the phone. Go, Reno, reach over and grab. What are you doing? They're going to stop. Get the phone, bro. I bet he missed the call. All that.
Tell someone new to do it. Make Liam do it.
I'm sure they'll call back, so we'll have version 2.0. All right, how about our initial velocity in our vertical direction? What is our number here? Carter, you want to put some extra sig figs in there? Or we good? We good with 3? I made this. These numbers work out for a reason, so let's at least not have a bunch of digits to worry about. Okay, so here we go. How does this help us? Now we've dissected the initial motion. What is the first question?
Max height.
Max height. So max height. I'm going to apply some critical thinking to this. And I'm going to say, all right, if we're talking about height, which component of the motion, if this motion has 2 components, right? There's a horizontal and there's a vertical component of this. If we're talking about max height, Which of those two seems like it makes the most sense? The vertical one. All right, so let's. You guys all have the drawing in your notes. So we're talking about max height. We're talking about vertical parts of this. So let's do. We know what we're working with here. Start with the full list of variables. Again, we may or may not fill all these out. Who knows?
Hold on, sorry. Wouldn't you be able to, like, sort of count each time until, since it'll hit 0 in the middle, count how many seconds it'll take for gravity to bring that vertical height to 0?
Yes. But we don't care about it returning. We just care about the height for now. So to your point, yes, we'll get there. You're just a step ahead of us.
Acceleration is negative 9.8 meters per second.
Okay, so let's start filling in things. So what's our acceleration? How do we know that? Gravity. Gravity's only working in the y direction, right? So we know what our acceleration is. What else can we fill out here? Final velocity is what? Why 0? Yeah, so we're talking about the peak height. So right as it gets to as high as it's going to go, right, it's moving up and then it's moving down. So in that split second at the top, at the peak of the motion, your velocity in the y direction will be 0. What else? Yeah, so what was our initial velocity in the y direction? Was it 20? Ah, why 12 and not 20? Yeah, 20 was the diagonal initial, right? But we're only talking about vertical motion here because we want to work with gravity and acceleration. We want just the vertical motion. So we need just the vertical component of the velocity, which was 12, right? Yeah.
Would the app be 6?
Sure, yeah. Could we solve for V average?
Yeah.
Sure. And what are we looking for here? This number? So let's go shopping in our list of formulas and let's see what can help us. So is formula number 1 going to help us? Why not? Yeah, so we're missing both of these pieces. We have 3 variables here. We only have one of them. That's not going to help. Will this one help us?
Yes.
So what do we have here? Do we have this? Do we have this? We have this? We're just missing time. Okay? So that could help us. Are we trying to solve for time?
Kind of need it though if we get distance.
But you can use the bottom.
Okay, so to your point, let's shelve this. We could solve for this, right? This would work, but this gets us time, which then, well, now we got to do 2 problems. So we already solved for this. Would this one work? We're missing distance and we're missing time. What about equation number 5? That's our winner. We have this, we have this, we have this. We're just missing distance. So could you solve for this? Yes. You could find time. We're just not asking for that. Right? So it would not be wrong, and you're going to get the same answer, but you're just going to do extra work versus choosing the right equation to begin with. So let's write that one down. And let's start plugging and chugging. Well, first off, what goes away?
Yeah.
This goes away, right? This was 0. I'm going to have 0 equals 2AD plus VI squared. Let's plug in. 0 equals 2 times negative 9.8 times D plus VI squared, 144. And now this is just algebra stuff, right? 2 times 9.8 is what, 19.6 negative d. Distance equals. Anybody do the math here?
Did you ever start recording?
Huh?
Did you ever start recording?
I think so. I hope so. Yeah. So again, what is this number? What does this number mean? It's how high it gets at its peak. That's all we asked. That's all we solved for. Easy peasy. Let's keep going. What was question number 2? And again, if I went through the math on that kind of quick, or the algebra, trying to get to all of this, you might take some time to work out the algebra in that, yes? Never mind. Brady.
But if we just find the time, can you just like double it? Like for the vertical?
Did you have it before and the end? Because we can use the numbers we got to get the first half of the time.
It's very insightful, very perceptive, and also very correct. So, could you find the time in the last problem? Would that be the answer here? No, why? Yeah, that's half the story. Right? Now, to your point, could you double that? Yes, sure, that would work. But there's danger here. Right? Because the danger here is you come back to the first problem. You rip through this. Right? We solve for this, 7.35 meters. And then you do the math and you find out the time here is whatever it is. What's the danger? Yeah, you figured out half the time. So if the question 2 is like, hey, how much time? Ooh, I have time right here. 1.3 seconds or whatever it is. You move on. You've gotten the problem wrong. So I would caution you on, you're right. Yes, that would work in this case. But be careful with that. Be careful with just some number, right? What was the third question on your thing? Total distance. Well, wait a minute, Clymer, I already found distance, 7.35 meters. That was height. So that was a distance number. That's an answer in meters. That's where this gets difficult, and you need to be methodical and you need to be careful in what you're solving for and when, and understanding what the question is asking. Oh, I got a number in meters right here. That must be it. Well, maybe. For height, it's right, but does the ball necessarily go the same distance as it went out as it goes up? No, definitely not. Same thing with time. Hey, I found time here. If you don't remember that you only solve for half of the total time, and you just get some number in seconds and you write that down as your answer, you're going to get into trouble. Right? So you're right, and that's 100% correct. I'm just cautioning to be careful. So let's pretend that we were not insightful. Let's try and find this a different way. Right? So let's try this a different way. Let's do a trial run here. Let's consider our horizontal motion. We haven't used that yet, right? Let's see if we can solve for the time in the air using what we know about the horizontal motion. Just to do this. Let's try it. Can't hurt. You guys know the drill at this point. Let's start filling in some blanks for the horizontal motion this time. So what do we know? Can we fill in any of these blanks? Let's start with that. Okay, initial, we solved for what? How much was it? 16. Okay, right off the foot. Your initial motion in the horizontal direction was 16.0 meters per second, okay? What else?
Final is 16.
Final is 16, it's the same, why?
Because the only force acting on it is gravity because it's horizontal.
Yeah, so does gravity affect the horizontal velocity? No. From your, look at your original triangle.
Oh, okay.
Right? That was your initial component of that initial velocity was 16 in the horizontal direction.
If you solve for the time in the first equation, wouldn't because you just put time for this one too? Because you're not going to have a different time.
Yes, but remember, in that first equation, we only solved for half of it.
Yeah, so you have one by
Right? So to your point, yes, we'll get there, but yes. So our final velocity is also 16 meters per second. What's our average velocity then? 16 meters per second, good. Acceleration is what? There's no acceleration? Why? Yeah, we're at a constant velocity, right? This is Newton's first law. An object in motion is going to stay in motion unless acted upon, and we said no air resistance, so what is acting in the horizontal direction? Nothing, right? So our acceleration is 0. So now let's do the same drill we've done before. This is it. We don't know the time. We don't know the distance. Can we use some equation to get there? Well, let's try it. Will equation number 1 help us? No. Will equation number 2 help us? Actually, no, right? Because acceleration is 0. VF minus VI, 0. So you got 0, 0 in time. You're not going to be able to figure out the time. This we already solved for. What about this one? Again, we're missing 2 variables in here. And what about this one?
Wait, there's no time.
Yeah, there's still no time.
We're gonna have to solve
The acceleration is 0. This and this are just going to be equal. So does the horizontal motion, as listed here, is this going to help us get anywhere?
Can't you find the distance and then use the distance to find the time?
Yeah, but not with just horizontal motion. We don't know the distance. That's what we're going to ask that in the next question. Right? But right now we don't know what it is. We kick the ball, it goes somewhere, but we don't know that yet.
Why don't we find that first and then use that to find the time?
Yes, I agree 100%. Right? So let's consider instead the vertical motion. Horizontal motion was a dead end. Let's see if the vertical motion will help us. So what is the total vertical motion of our ball for the whole time it went, for the whole kick?
0. Like on the distance?
I don't know, let's see. VI, VF, A, D, T. Now in this case we're talking about total, right? Vertical motion. What was our initial vertical velocity?
12.
Yeah, we already had this, right? This was the vertical number. Meters per second. What else do we know here? What's our final vertical velocity? What is it? Negative 12. Why? How? How do we know this?
Because it's falling.
Yeah, because what does the ball do? It goes up, then it comes back down. And since we talked about the exact same height, it's going to have what final velocity? Dash? What's up?
What's that?
What's that?
Would this 2 sides be equal?
Yes.
Okay.
In this case, because they landed at the same height, yes. That might not necessarily always be the case, but for now, yes. This is just a standard arc throw. We kicked it from here. It landed on the ground, right? What's our acceleration here? Yeah, because we're back to vertical, right? What's our V-av in this case?
So we said vertical was 0?
Think about it.
Well, Hold on. Yes, but that was question 1. Why was it 0 for question 1? You're right. You're 100% right. But why was it 0 in the first question? Yeah, because we were solving for max height, right? Now we're solving for it goes up and it comes back down. So when it hits the ground, kind of like the ball being tossed here, right? When it comes back and hits your hand, it's got that same velocity, just in the opposite direction. So now, with these bits and pieces, can we solve for it? Oh, what was our total distance? Vertical total distance. Why 0? We started on the ground and we kicked it, ended on the ground, so your total displacement vertically is going to be 0. So now there's only one thing left. Which equation are you going to use for time here? I know the one I'm going to use.
D equals half AT plus VIT.
No.
Equals
Why don't you make it much harder?
distance over time.
How would that?
No. Equation number 2. Do we know all these things? Do we know this? We know this, we know this. We can solve for time. Dash. Theoretically, I like it. I'll get,
These two are the same. What's stopping us from doing Socrates to find this and then just doubling it?
Yeah, that's what we did.
this finds you velocity, not a distance, right? So that's a good thought, but you got to keep your units straight.
We did all of this so that we could figure out for this one because we couldn't get this one. But if we would have plugged this one into the bottom equation, we would have gotten 0. Like, if we would have put this into the last equation when we had just this, wouldn't that have still come out as 0 because acceleration was 0? So that would have
Well, actually, yeah, that middle part would go to 0, but that would still leave the two sides equal to each other, which is true. They're both equal to each other, but it won't help you solve for either of these two
so we
things.
ended up getting distance as 0. Is that just a coincidence?
Well, that's vertical distance is 0. Horizontal distance, hold on tight, that's coming up
So
next.
we used all of this to get the time, don't
Yes, yes, yes.
This,
Uh-huh.
You're supposed to round
here.
Yeah.
from this number. Because this is half of it. So
Yes.
sometimes there's just things you want to get that data.
Distances won't work like that. But I see what you're saying, but you're conflating two different things together. Because the angle is what its velocity is at, not necessarily distance. So there's a relationship there, Dash, but it's not a pure SOHCAHTOA one, if that makes sense. All right, here we go. Let's, did everybody plug this in? Negative 9.8 equals, VF was negative 12, minus VI was 12, over time. Negative 9.8 equals negative 24 over T. You know how I'm going to do this. Cross multiply and divide. Time equals.
I'm still right. I'm still right. It's making fun of me because I rounded in the first equation because I wanted it to have the time value in the vertical equation, which is half of it. So I just multiplied it by 2. But it's 2.46 in my equation.
Don't let them pick on you.
I know, right?
All right. Don't let them pick on you, especially with math, you know?
He's off by 100 if that's a wrong answer. Would you mark that off as a comment?
Carson, yeah. For you, no. You'd be fine. You'd be fine.
Well, I got the right answers.
All right. So, again, let's think about what is this? What is this time? This is the total time the ball took to be kicked and to land some distance away.
I did not.
So now, yes. Now what can we do for question 3? What was question 3?
I already did the math. My equation was done.
What's the total distance this ball went to where it hit the ground. How do we solve this? Well, now it seems like we're probably going to want horizontal information, right? Luckily for us, we already did this. So this is a quick fill in the blank. Now what do we know that we did not know when we first filled this out? We now know the time. Now we can just use our easiest equation of all time, 2.2.45 seconds. VAV equals distance over time. 16.0 equals distance over 2.45. 39.2. Now, again, to our point, if you really understand what's happening here in this scenario, we could go all the way back to question number 1.
It's all right. No, you're wrong.
And
Your own answer's wrong.
if we find this time here, now you may or may not even need that, right? In this case, to answer question 3, we could have used this. But again, what we have here would only equate out to half of the time. So if we solve this out, since we have all these things, let's do it just to make sure we're not all going crazy. Let's solve for time. So VAV, distance over time. Well, we know VAV is 6. Distance was 7.35. And time, let's just make sure we're not all crazy. Somebody solve this. 7.35 divided by 6.0.
You think I got this?
Yeah, I thought you did.
Then goes his head. His calculator out there. It's like, maybe I can say that.
So is this half of the time we calculated for using the vertical motion?
I mean, yeah.
Yes-ish. With enough sig figs, we'd all get there.
Sig figs, like I said.
With enough sig figs.
That is what on my paper.
Yeah, for sure, for sure.
0.02.
As much as I would love to jump into an argument about sig figs, boys, let's.
Even though I'm right about it. Why is it not on my paper?
That's so bad. All right, so again, this works, but there's a cautionary tale in here that if you aren't 100% confident on what exactly is going on here, you could get into some trouble. And this will especially be true in more complicated problems. So to give you a preview of where this goes from here, here's our guy. Right? So in this problem, this is projectile motion. We're riding off a cliff, stunt driver. In this case, the cliff has some height. Where do you land? Or I can ask another way. I can say, hey, wait a minute, same guy, but this time the cliff has a different height. We're trying to get to some distance. I can mix up all of the different things here. Right? I could even do a problem if you want to get really, real outrageous with projectile motion. You can have a cliff. Let's draw a cannon. And here's our water. Here's our pirate ship, of course.
Yeah.
Oh, yeah? So it won't be that bad.
So I know my artwork is legendary, so please excuse this. But now you could have a situation where you have to do this. Bro. What just happened? Broke it. Where now you have an initial velocity here, and like this is a height number, and you have the number of the cliff is 50 meters tall, and the boat is this can get messy and complicated. No, maybe.
What's levitating on the water?
What's that?
What is levitating on the water?
Yeah, it's not touching the water.
It's not even touching.
It's a special kind of boat. It's a hydrofoil. The actual things are in the water.
I know.
Climber, I can't answer this problem. Your art is too terrible. I get it. That's fine. That's fair. That is a fair assessment. Okay, so to your question, is this a more complicated scenario than what we just solved? Yes, for sure. But at the heart of this, we're just talking about two different motions that are kind of tied together. Right? So the time that this thing takes to go in some horizontal direction, the time it ultimately takes to go up and down, those are going to be the same. Right? You're going to have some SOHCAHTOA in here maybe. You're going to have vertical motion, horizontal motion, and they are kind of tied together. So again, today your assignment is to let this marinate. Simmer, indeed. Possibly boil over the stove and cause a fire. I don't know.
Grease fire.
Grease fire. Yes. So next week, we're going to get into this and get a little bit more messy. Tomorrow will be a little bit more fun. Where did I put it? Tomorrow we're going to build a thing. It just wouldn't be projectile motion if we weren't flinging things all over the classroom. So you guys are going to build this thing here.
Are we going to have a war and try to take each other?
No, maybe. No.
Another investigator, or is it just like a thing?
Just a thing to do.